Hey there! Welcome to my tutorial on the rocket game. So this tutorial is about building a casual style rocket game where you can control a rocket ship through a small solar system. Get to the edge of the screen, you wrap around to the other side, kind of like Asteroids. And I'm going to kind of develop this on the fly as we go through it, but we should get a good feel for how to make a nice little rocket game with gravity and a propulsion system and hopefully some pickup items and a little mission to accomplish. So I'm going to go ahead and get started first by setting up my project. And what I like to do usually is just create my directories. So I'm going to have a scripts directory. I'm going to go ahead and create we'll call this a models directory. And I'll go ahead and make another folder for any prefabs that I might make. And another one for materials. And you can create more later. I think that's a good place to start. Okay, so we've got these going. I'm going to go ahead and, just so that this isn't using some real basic graphics, I'm going to go ahead and look on the asset store for a free rocket. Let's see what we can find here. Let's go ahead and hit free only, and let's take a look. Rocket. I don't see any free rockets here. It's interesting. Actually, I do. I see this pack of rockets. Okay, well, that looks interesting. Why don't we go ahead and use this? Go ahead and import that. Kind of clean, cartoony style rockets. So we'll close that. And let's just move this into my models directory. Let's find prefab here. I'm going to go with a red rocket. We'll just drop it in the scene. Oh, look at that. We can kind of pick the one we want. A lot of interesting rockets here. Let's try this one. Nice long rocket. Okay, so we've got our nice long rocket here. Let's take off the rotation. Oh no, actually we want that rotation there. -90. We want it to face the camera. The camera might be a little too close right now. We want the rocket to maybe be about that big. So why don't we go with that big? We have this in 4K mode. We really don't need that, but 16:9 is fine. Let's turn off the stats there. And let's not have a skybox as our background. We're going to be in space, so let's go with a black background. Selecting our camera, set the clear flags to solid and the background there, background color to black. Okay, let's go ahead and save this. So we see we need another folder. We're going to call it scenes. We'll call this our main scene. So this is our main scene for now. If we end up doing some different things with it, we might want to change this, but for now we're going to call it our main scene. So the rest of this tutorial I'm going to focus on getting this rocket to move with the keyboard. And of course, if you want to change this to other inputs, it's fine. You might want this to work for a mobile device or with a controller. So then you can use other things, and maybe we can use some inputs that are generic enough that we can use other controllers, but may not necessarily work for mobile. I'm going to go ahead and create a player class. What do we call this? Player controller. And we'll just drop this on the rocket for now. Okay. So we're going to open that up. And there's going to be a couple things we're going to want to do. First, we want to give our rocket a velocity. So velocity, in this case, we really only need a vector 2. our velocity because we're working in 2D space. We're only going to be looking at it from one angle. We want the ship to move around on the X and Y, not the Z. So we'll be moving around in any of these directions, but we will not. Let's see, where's our camera? We will not be doing any of this. All we'll be doing is this, and we will be moving around in any given direction. I see, I'm looking at it backwards. There we go. So that lines up with the camera. Okay, so we've got our player controller. We've got a velocity vector 2 here. I'm going to go ahead and just make this visible in the editor so that we can, and that's serialize field, so that we can see it. So we want to see what's happening to our velocity. So a quick simple test is that if we hit the up button, in this case I'm going to make it W. Actually, yeah, I'll make it W. And a quick way to do this is we just check in the update loop if input.key code, .key, get key code .w, then what we want to do is we want to tell our velocity to plus equal a new vector 2, and since we're going to be doing W, that'll be up, which is the Y direction, vector 2, and we'll move it, let's say 3 units in the Y for now. So now we're going to assign this back to our model. So our position plus equals velocity. So our position equals our velocity plus transform dot position. And this is a vector 2 to a vector 3, which is the problem. Actually, what we want to do here is cast this to a vector 3. That should be fine. So this will add the Z property onto this velocity, but there's no data for the Z property, so it should be a 0. Let's go ahead and get back into the editor and play. And you can see our ship just took off. So maybe 3 is a little too high. We'll try 1. And 1 will probably be too high as well. And so you can see quickly that we need some way to fix this so that we can constantly see it. If we want, we could make it a child of the camera. I'm sorry, we could make the camera a child of the rocket. So now it's moving. It doesn't look like anything because the camera moves along with the rocket. So that's kind of silly. So maybe what we want to do is anytime this guy goes out of the bounds of the camera, we want it to flip to the bottom. So there are a couple ways we can do this. One way we're going to do this is we're going to check if the player is inside the screen position. So the screen position is anything that's visible to the camera. And the way we can check this is we can convert its position to a screen position on the screen, and then figure out if its screen position is beyond the screen. There are other ways to do this, but we're going to try this method here because it's fairly easy to implement. So here we'll just write check if we're off screen and resolve. So here what we're going to do is we're going to reference our camera. And really we don't want to do this every time in the update loop, so we're going to get a reference to the camera before we get in the update loop. We're going to get a vector 3 screen position, and we're going to call the camera, and the camera has a utility method here that returns our world point to screen point. We can say to viewport point. You can see it says transforms position from world space into viewport space. The other one does from world space into screen space. I think either one of these could work. I'm going to try viewport. I'm going to send in our current position. And now we can debug log this just to see. Of course, we probably don't want to do that in the update loop. It'll just spam our console. So why don't we wait on that? We're going to just try and implement this first. And if we run into errors, then we'll start debugging things. So we're going to check if our screen position is less than 0. Then our screen position dot y. If I spell screen properly, screen position dot y should equal 1. So our screen position x and y go from 0 to 1. So x is 0, x on the left is 0, x on the right is 1. Y on the top is 0, Y on the bottom is 1, I believe. So let's see. So if it's less than 0, let's put it at 1. So if it's less than 0 up here, we'll put it down here. Means it should be traveling up. Else, if our screen position dot y is greater than 1, then we want to put our screen position dot y at 0. So I think that should work there. And we're going to do the same thing with the x position. If screen position dot x is less than 0, then screen position dot x equals 1. Else, if screen position dot x is greater than 1, screen position dot x equals 0. So that's us getting the screen position. Now we've got to transform that screen position back into a world position. Again, we're going to use the camera to do this. So we're going to call the transform.position. We're going to set that equal to the camera. And we're going to say viewport to world point. And we'll send in our screen position. Okay, so let's just look at all that code together. So we're in the update loop. Every time we run through the update loop, we get a reference to the current camera. We set it equal to cam. And maybe we don't want to do this here, so let's do this somewhere else. Let's get that out of here. We'll put this in our start method because our start method fires off once. We're going to make a reference to a camera up here called cam. That way we're not creating this locally inside of the start. So now it's a global variable inside this class, or it's a class variable. And now I can call it without having to cause extra overhead in the game. So then I create my vector3 screen position. I set it equal to the camera viewport point based on my rocket's position. Then I check the position, whether it's greater than or less than 1 in the y, and whether it's greater than or less than 1 or 0 in the x, and then I correct that position based on my checks, and then I assign the position back to my rocket. Okay, so let's test this. I'm going to go back into the editor, hit play, and I'll hit the up. And it does work, although I am moving way too fast. Let's just adjust the speed that we're moving. So we're moving 1 times time dot delta time. So we're moving 1 unit over 1 second there. There we go. It's a little better. So now this movement that I've applied here, we're going to find that there's an issue with it. If I rotated the ship for some reason this way and I press up, it's still going to go straight. And I can go ahead and do this. Let's say we want our input dot get key code dot, we're going to say A to rotate this thing left, right? Or rotate it counterclockwise. So what we're going to do here is we're going to say transform, type dot rotate, and we're going to assign a new vector 3 because our rocket is in 3D space. The rotation does require vector 3. You can see rotate actually uses a Euler angle. I think there are 5 overloads. You could probably send in a quaternion or a Euler or specific degrees. So we're going to rotate, I don't know, -2 degrees every update. Multiply that by time dot delta time, so it happens over each second there. And that should be that. Okay, so let's take a look at this real quick. So this only rotates us counterclockwise. So let's go ahead and see that. So I'm going to hit. Now you can see how slow that is. It's actually rotating me, but it's so slow. If you look up here, you can see there's some rotation happening. So maybe we want to rotate more than 2 degrees. Let's say we want to rotate 10 degrees. There we go. That's a little faster. Why don't we rotate 25 degrees? Should be. And we can modify this in the future so that we can change the speed of rotation. But now I'm going to hit up. We've turned sideways. I hit up, and we're not moving in the direction that we're rotating. So the problem here is that when we assign our velocity up here, we're assigning it only in the y. What we want to do is we want to assign it in the forward transform. So every game object has a transform.forward. Well, it has a transform.many things, but transform.forward, you can say times acceleration. And acceleration can be a specific speed. For now, we're just going to assign that in the editor. Serialize field. And we'll make this a float. Acceleration equals, we'll say it was, I don't remember what it was, but we'll say 4. So vector 3 forward times acceleration. And we're setting that equal to our velocity. You can see there's a red underline here. The problem is that the velocity is a vector 2, transform forward is a vector 3. So one thing that maybe we could do is just set this to a vector 3 and never really mess with that z component, and that would solve that. So why don't we do that now, and that'll just ease up some of the confusion. Okay, and I will hit play. Now if I hit up, we are moving super fast. Okay, moving way too fast. So vector 3 times acceleration times time dot delta time. There we go. Okay, so we hit up. Now rotate, and you can see it is starting to move. Now another thing that's really bothersome right now is that we can move way too fast. So another thing we can do here is we can clamp the velocity. We can set velocity equals math, well, equals new vector 3. We'll say velocity dot x, but we'll say math f dot clamp velocity x, and we'll clamp it between 0. Well, no, we want to clamp it between We'll say min velocity and max velocity. And we'll do the same thing with the y component. So we'll just copy that there. And then the z component will be 0. Just to make this a little more legible, let's put these on separate lines. You can even put it on a separate line like that. Makes it a little more legible. So we have this line flying off the screen here. Let's go ahead and get rid of our comment. Let's add some useful comments for ourselves. Move forward. Rotate left. Clamp velocity. Assign new position. There we go. So that's kind of nice. We've got some nice comments there. Let's add our new min max values. So we're going to make a float min velocity. And we won't add any default value there. Serialized field, float, max velocity. So now we've got to set these here in our editor. So min and max velocity just popped up. I'm going to say min velocity is going to be -50 and max will be +50. I really don't know what those values should be. You can see all of a sudden it kicked in and we are flying because it's clamping between min and max. That's why, because this already has a negative on it. So let's remove that negative, because we put a negative value in here, and then there's a negative value in here, so it's clamping it to 50, between 50 and 50. Okay, there we go. So now it's 0. So 50 looks like it is out of control. Let's try -5 and 5. That still seems too fast. Why don't we try -1 and 1? There we go. Let's go ahead and add a rotation to the right. Let's do this, rotate right. And you can see it's pretty much just doing the opposite of left and adding the key D. We can add an OR to check for the arrow keys. I'm not going to do that just yet. So this will allow us to rotate. I'll make this 50 just to be able to rotate faster. -50, +50. And bake in these values, min velocity 1 and 1. Does look like our up key code isn't kicking in the whole time. So you can see our velocity is just 1, -1. sure what's going on there with. So let's reduce our speed. Let's say that's negative 0.25. Negative 0.5. 0.25.
I'm a dirty diaper. 2 seconds ago I was a clean diaper, but oh mama, get a load
It's
of me
interesting.
now. I'm like
It only
rotten
starts
egg
kicking
steak
in our
with
acceleration
You're trying to parallel park your not so
once
winning
we hit
old
a certain
Alabama's
rotation.
win. You battle the size of a parked car, and if you've got credit insurance, that sticks. So get Allstate, where agents
So
help
let's
protect
take a
you
look
from
here and see what's going on with this ship.
Click the banner to see if you're protected.
Let's see. Don't want global, we want to see the local.
We started using ZipRecruiter about
You
3
can see
months
this
ago.
blue
Like,
arrow
the
is
job
our
was posted
forward
200
transform.
job boards, all the top sites.
All of the candidates came to my dashboard, and it's easy to
So
compare them.
And I couldn't believe the number of great applicants we got. I don't know how we hired before ZipRecruiter.
this doesn't seem right here because every time
Where your job is
we
just
move,
one click away from 200 plus job sites. And right
it
now you can
is
try ZipRecruiter
just
free. Just click the banner now.
moving us
ZipRecruiter.com/Spotify. That's
diagonally up,
ZipRecruiter.com/Spotify.
diagonally down.
Stop paying for uploads that aren't up to speed.
It's interesting.
Only
So
Files gives you equal upload and download speeds.
velocity plus
Click the banner
equals
to get
that.
150 meg internet, TV, and phone for
Transform
only
forward times
$79.99 per month
acceleration.
online for 1 year. Get Fios and harness the full power of the internet.
Rotating. Okay. That should be fine. Okay. So another way we can do this clamp, which might be a little better, is if we just do a vector 3 clamp magnitude. We can say velocity. We can just say max velocity. I think that should work. So let's just do this max velocity. We don't really need the min velocity anymore. So this should just take the length of our vector 3 and check it. And no matter which direction we're facing or we're flying, the magnitude of the velocity would be the same. So if we're flying top left, it could still be a magnitude of 5. Flying top right might be the same magnitude, doesn't matter. So this just clamps that to our max speed, in this case 1. And then we still add our velocity to our position. So that's right. And then we're doing our screen check. So let's just look here real quick. So there we go, we've got rotation of both sides. Okay, so that looks like that's what our problem was. We were clamping the wrong thing. So we get our max velocity there, 0.25. Let's do that. So that's our max speed now. There we go. That's clearly we can just stop this ship on a dime. Maybe we want that, maybe we don't. Okay, so there we go with that. So that's a good start for the player controller. There are other things that we can add in here that we can talk about in the next tutorial, including things like gravity, adding some kind of particle emitter to look like our exhaust or jet fuel is burning every time we hit the move button. We could add some friction. Actually, friction is something I think we can go over real quick right now. So friction, if we pull up our script, can be easily done by multiplying our velocity times some fractional amount. So if we want our velocity, actually, let's not multiply our velocity by that. Let's multiply our, we want to multiply our velocity, what am I saying? Let's do that here. Velocity times, and let's say friction was 0.75. That means every update, if we don't move, our velocity will slow down. So this number, the magnitude of our velocity will get smaller. So let's say it gets up to 0.25 or gets up to 1, but it'll just slow down on its own. And here you can see it's not doing anything because we're not adding that back into the velocity. So actually, let's go back here, save. We could assign this vector plus or times 0.75, and then we have our velocity being assigned back to itself with a friction amount applied. So now you can see my speed is no longer as fast as it was. If I let go, it stopped. It stopped pretty abruptly. So you can see this feels more like a car or something. So if we want to set this more to something that's space-like, something that's really frictionless, maybe 0.98. Go ahead and multiply that. Go ahead and hit play there. Let's just look at that. It's like we're sliding on ice. So that's kind of cool. Maybe it'd be nice for a rocket to turn faster. So let's try and just update the rotation speed. So we could either remove the time delta time and just use some sort of, let's set this back to 5 and this to 5, and we'll just multiply this by 0.75. And I'm coming up with these numbers off the top of my head right now, but usually it's best to expose them in the editor when you're first starting, just so that you can get a feel for what numbers work. And then look at that. Oh, it's nice. Then you could even make a config file that could help you just kind of bake those numbers in there. So there's a lot more response. This is like the Ferrari of rockets. So it's kind of fun. I'm doing donuts with my rocket here. Alright, so I'm going to leave it there for now. I'll pick this up again in the next tutorial. Okay, I hope you learned something there, and I hope this gives you some ideas to make some cool projects. Alright, see you next time.